Ever notice how, like, messing up can actually be the best way to learn something?
Yeah, definitely.
I once put salt in my coffee instead of sugar. Totally not my proudest moment.
Oh, wow.
But it got me thinking, what if AI could learn from its mistakes the same way we do?
Hmm, interesting.
Well, that's what has me so fascinated by this research paper you sent over. V-STAR, training verifiers for self-taught reasoners.
Yeah, it's a really cool paper, and it really gets to the core of how we can make AI more efficient by actually learning from mistakes rather than just trying to avoid them.
Right. So let's break this down a bit. When they say self-taught reasoners, what are we talking about exactly?
So imagine you got an AI that's trying to, say, write code or solve a really complicated math problem.
Okay, got it.
That's your self-taught reasoner. It's trying to figure out solutions on its own based on what it's learned.
Makes sense. So then where does the verifier come in?
Think of the verifier as like a judge or maybe even a really good teacher. It looks at the solutions the reasoner came up with, and it figures out if they actually work.
Gotcha. So it's not just about getting the right answer, it's about understanding why an answer might be right or wrong.
Exactly. And that's where this V-STAR thing gets really interesting.
Okay, I'm all ears. Tell me more about how V-STAR actually works.
Well, the paper uses this example called the Andy walking problem, and it's a really clever way to illustrate the whole process. So picture this. Andy walks a certain distance to school, right?
Okay.
Then he walks back home.
All right.
And finally, he walks to the market.
So the classic triangle scenario.
Yeah, exactly. And the question the AI has to figure out is, how far is Andy's house from the market?
Okay, sounds simple enough. What happened when they gave this to the AI using V-STAR?
Well, here's where it gets really interesting. The AI actually came up with two different solutions, which the researchers labeled U and U2.
Interesting. So did one of them get it right?
One did, but here's the cool part. Even the solution that got it wrong actually followed a logical step-by-step process. It just made a wrong assumption early on, which then threw the whole thing off.
Fascinating. So even in its mistakes, the AI was still demonstrating some level of understanding.
Precisely, and that's where V-STAR comes in. The verifier was able to look at both the correct and incorrect solutions and figure out not only what went wrong, but why.
Wow, so it's like having an AI detective that can retrace the AI's steps
Yeah.
and pinpoint exactly where it went off course. That's amazing.
Exactly. And, more importantly, it can then use that information to help the AI learn from its mistakes and do better next time.
It's giving me serious aha moment vibes over here. This is like next level AI learning.
Right. It's about more than just giving AI information. It's about teaching it to think critically, just like we do.
I'm already blown away, and we're just getting started. This is why I love doing these deep dives, always something new and mind-blowing to discover.
Absolutely. And it gets even more interesting when we look at how this V-STAR method actually performs in practice.
Okay, give me the details. I'm ready for more.
So one of the most impressive things they found was how well this thing they call the 7B V-STAR model performed.
7B V-STAR model. Okay, what's with the B there?
Yeah, so that B stands for billions of parameters.
Okay, so like parameters, are those like the settings kind of for the AI?
Yeah, exactly. Like you can think of them as a way to measure how complex the AI model is.
So bigger brain, more complex thoughts, that kind of thing.
Yeah, pretty much.
Yeah.
And what really blew the researchers away was that this 7B model, even though it was actually pretty small, it did just as well as this much bigger model called Codelemma 34B on some of the coding tasks.
Wow, that's wild. So it's not just about throwing more computing power at the problem. It's about like training the AI in a smarter way.
Exactly. And that's huge for making AI more accessible. We don't necessarily need these massive data centers to get really impressive results. But it's not just about efficiency, right? The paper also gets into how V-STAR achieves this through like a really clever approach to learning. They compare two different kinds of verifiers, which they call DPO and ORM.
Okay, I gotta be honest, those acronyms are a little intimidating. Can we unpack those a bit?
Yeah, for sure. Think of them as two different teaching styles, so like DPO or direct preference optimization is like a mentor who's like guiding the AI by showing it different solutions, one good, one not so good.
So like showing it examples and letting it figure out what works best.
Exactly. It's about helping the AI develop a deeper understanding of the problem-solving process itself, rather than just like memorizing the right answer.
Yeah. Right. Okay, so what about ORM then?
So ORM, or Outcome Supervised Reward Model, that's more like a strict grader,
Yeah.
Just cares about whether the final answer is right or wrong, doesn't really explain why.
Interesting. So it's like DPO is all about the why and ORM is all about the what.
You got it. And kind of like we see in real life, it turned out that the DPO approach, that focus on understanding, led to much better results.
Yeah, it makes sense, right? Like, I remember trying to, I guess it was bake bread, actually, and I kept messing it up until I finally figured out, like, the science behind why the dough rises.
Totally. And that's what's so cool about this research. It's not just about building AI that can do specific things. It's about building AI that can actually learn and adapt.
It really makes you think about, like, how we approach learning in general, you
Sure.
know? Okay, so we've covered a lot here. Self-taught reasoners, verifiers, different teaching styles for AI. Why should all of this matter to someone who might not be, an AI expert? This whole thing kind of reminds me of that saying, embrace the mistakes.
Right.
Like you hear it all the time in creative fields, right? That's where the real learning happens. It seems like this V-STAR thing is kind of applying that same idea to AI.
Totally. And that's a big part of what makes this research so exciting. It's not just about AI processing information, it's about AI actually understanding why something works or doesn't work.
Yeah, like we're not just talking about AI that can write code faster. We're talking about AI that could potentially solve problems we haven't even thought of yet.
Exactly. Think about something like medicine, right? Imagine AI that can, like, analyze really complex medical data and then learn from its own analysis. That could lead to, like, faster diagnoses, more personalized treatments, maybe even cures for diseases we thought were impossible to treat.
Okay, now that's what I'm talking about. That's the kind of stuff that gets me really fired up about the future of AI.
Right. And this research is still pretty new, but the possibilities are, like, mind-blowing. It's like we found this whole new way of teaching AI.
Yeah, it's like we've moved from giving AI a textbook to giving it a tutor in a lab to experiment in.
Huh. I like that. And the more we let AI experiment, the more it can learn from those experiments, even the ones that don't go perfectly, right? That's how we get to those, like, groundbreaking discoveries.
This has been a really awesome deep dive. We've covered so much ground, from the really technical stuff to the big picture implications. So as we wrap up here, what's the one thing you hope our listeners take away from all of this?
If there's one thing I hope sticks with everyone, it's this. The next time you make a mistake, don't get discouraged. Just take a second and ask yourself, okay, why did that work? Because, like, that question, that curiosity, that's where real learning begins. And who knows, maybe one day AI will be right there with us, learning from its mistakes and changing the world as we know it.
Couldn't have said it better myself.
Hmm.
And on that note, we'll leave you with this thought. If AI can learn from its mistakes in things like math and code, what other areas could this apply to? We'd love to hear your thoughts, so head over to social media and let us know. Until next time, keep those brains curious and keep diving deep.